ACTI Lens Calculator is really a great tool. If you have a project that has a specific requirement that, for example, the camera has to be able to see the faces clearly from 200 meters, for example, how can a user actually know? There are so many cameras to choose from. Is it like a 30 times optical zoom enough? Should I go for the 10 times optical zoom? Should I have a higher resolution camera or lower? Everything will be answered with a single tool called Lens Calculator. And how to use it, just follow the steps. Before we start with the step 1, because this whole concept is related to the video quality, we need to understand what we mean by that. So I'm going to open the chart that gives you the understanding of the quality. So we made a simple scale. Of course, you can use the more scientific understanding. If your project requires pixels per feet or pixels per meter, you can reference to this number here, 200, for example, 200 pixels per meter or 61 pixels per feet. This is what we call 60% clarity. You can see that's how the 60% clear face and the license plate looks like. So now you understand. So if you have a project requirement, something like that requires 100%, you will choose 100%. Let us go back to this tool and then we will show how Lens Calculator works. But before we start, also, I would like to show where we find it. So on the main page here, and here is the link to the Lens Calculator. At the same time, of course, you could go to the project planner and find the Lens Calculator there as well. Okay, back to the tool. And which ACTI camera should I choose at the given distance? So this is the case, right? I can choose face or license plate. I have chosen face with a 60% clarity and 200 meters. And click to the side, and you see the list here. We have so many models, almost 20 models here. Most of them are speed domes, but we also have a zoom box here, zoom box here, and zoom bullet, right? And you can see their focal length, the maximum focal length that they are showing here, and the available resolutions as well, right? And here it shows that it can have this distance to the target. If you zoom in all the way, you can zoom 346 meters to see the face like this on the right side here. This camera can zoom in all the way to the target that is standing 270 meters away from the camera. And as it zooms into the target, the width of the scene at the target is this number here. So the scene is 13 meters wide in this case. And of course, you can add the models that you found. You can check something here and add them to the report. So you can actually evaluate. Let's say I just pick this, and our interesting models. I add them to the report. And later you can export this report to Excel and add it to your project. Okay. And now let's try this tool with a different way. And by the way, if you are not using meters scale, you're using feet, you can just switch over. And now this tool works the same way, but with feet, okay, and meters. Okay. There's another option. How far can I see with the selected camera? So this is the case where you are considering one specific model, but you just want to make sure what is its maximum capability. What do we do in that case? We choose the model. Let's say we choose the model. Let's go for the let's choose the model that is with the longer, let's say I-96, okay? I-96, speed dome. And what we see here is the information. Currently, the step 4 is that we're looking at the narrowest viewing angle. That means that we're looking at as far as possible. So the focal length is 129 millimeters in this case. We can recognize this kind of face with this clarity from all the way to 230 meters if we are using 2 megapixel resolution, which is available in this camera. These 5 are all the correct options of that camera specifically. So if you are switching this camera to the 1 megapixel resolution, then you will be able to see this kind of face all the way up to 153 meters and so on. If I now zoom out to the widest, okay, then you will be having this 4.3 millimeter position for the focal length, and the target will be standing 7.7 meters away to look like this image. If you want to specify any kind of middle position, let's say that what happens if I zoom into the 50 millimeter position, then you can actually do that as well. You can just manually run these numbers here at 50 millimeter zoom. It's somewhere zooming halfway, not all the way. You can see this object all the way up to 89.3 meters. If the requirement changes and you want to have higher clarity, you just change it here. And the situation changes here. Previously, we had 89, now it's 59 meters, right? So you can now add this model to the report as well. Now you have already 5 models in the report. And finally, you can export this report to Excel. You can do the same things with the license plate. You choose the license plate, choose the image quality that you prefer. Let's say it's still 60%. And then you can just start choosing the cameras. You can choose any camera here. And you have a lot of resolution options available here. With the maximum resolution here, it's 12 meters, and you can see with this clarity. And because this is the fixed lens camera, so you notice that if I choose widest or narrowest, it's always the same number. So if it's a fixed lens, it doesn't matter. It's at the same time, it's a wide and narrow at the same time. But if you choose the zoom camera, let's say like this one, for example, then you can see that the narrowest zooming in all the way is 12 millimeters. Widest is 2.8 millimeters. And you can see the numbers change. And you can add the model to the report. Now you have 6 models in the report. So this was ACTI Lens Calculator, which you can find from here.